All right, we're continuing with chords and arcs. So for number 7, DE is equal to this and FG is equal to this. Find DE. All right, so we have two perpendicular segments here that are perpendicular to the chords. What that means that the chords are congruent. So we're going to say 11x plus 15 equals 32x minus 27. All right, so I'm going to subtract 11x. You can subtract from either side. I usually try to leave myself with a positive number. I've learned over the years working with students, you're less likely to lose a negative sign if you do that. But you can certainly do it the other way. 21x is equal to 15 plus 27 is 42. And divide both sides by 21. So x equals 2. Now it says find DE. Again, like in the last video, make sure that you actually answer the question so that you get it right. So DE is 11x plus 15. So we're going to say 11, x is 2, plus 15. So we've got 22 plus 15. 22 plus 15 is 37. So DE equals 37. And that's our answer. All right, I'm going to clear the screen so that you can focus on just what we're looking at. So this one says find arc MP. All right, so MP is here. All right, so we can't do anything with that yet. What we can do is say that these two arcs are congruent because these segments are perpendicular to the chords, which makes these congruent. And these are congruent to each other. So we can say 9x minus 43 equals 5x plus 33. All right. So that gives me 4x add 43 and 76. All right, so that gives me x equals 19. All right, so if I have x equals 19, that means I can plug that in for x here and here. These two should be congruent, so they should be the same. But then if I have these two, I have one more arc, and together all three of those equal 360. So I can't find this alone, but if I can find these, then I can find the third one. So if I do 5, I'm going to come over here, 5 times 19 plus 33. And that gives me 128. All right, let's do 9 times 19 minus 43. All right, that should be 128 as well because these two arcs are congruent, so you can check that. All right, now I know that the whole circle is 360. That's something that you need to remember no matter what you're working on, is that the circle is 360 degrees. If you have a semicircle, it's 180 degrees. All right, so if I take 360 and subtract 128 twice, that gives me MP. So the measure of MP equals 104. And again, if you take these three arc lengths and add them up, that is 360 degrees. All right, looking at number 9, in circle Z, so the circle is named by the center. Most of the time that's how it is. So in circle Z, if RS, okay, RS is 18, that's your chord length. So we know that TU is also equal to 18. And the measure of TY is 42. Then we know this one is also 42, and etc., etc. All right, so find the measure find each measure. Okay, so TV is half of this chord. We know that the whole chord is 18, so half of 18 would be 9. TU, this chord is congruent to this chord because these tick marks show that those lines are perpendicular, those are congruent, so the chords are congruent. So TU is 18, just like RS. And WS, here's WS, so that's half of the arc again, so that would be 9. And then the measure of YU, so we're looking for an arc measure, YU, okay, that's congruent to TY, so we know that's 42. And the measure of RS, so the measure of RS is this whole arc, so that's 42 times 2, or 84. All right, for number 10 in circle I, if BG, so BG is the half of this arc, is 17, that would mean the whole arc would be twice that. So we know the whole arc, like BC, or the whole distance from BC would be twice 17, or 34. And the measure of CHA, here's CHA is this big part here. We know that all of that equals 256. And we still know that the whole thing equals 360. So while I'm looking at this, 360 minus 256 is 104, and then 104 divided by 2 is 52. So each of these arcs are going to be 52. Again, because the radius are, because these are congruent, that means the arc measures are also congruent. All right, let's see what it asks. BC, so BC, we already said the arc BC is 34, so the line BC would be 34 as well. All right, so FB is half of the arc measure, so it would be the same as BG, so it would be 17. And then we have the measure of arc AB. The measure of arc AB would be 52. And then the measure of BC is also 52. And the measure of EC. So EC is going to be half of the 52. Half of 52 is 26 degrees. All right, again, these are easy to check because you know that your entire circle has to equal 360. So if you do 52 plus 52 plus 256, you will get 360. All right, for number 11, QM is here, and MR is here. Since those are split by perpendicular bisectors, that means these chords have equal sides here. So this bisects it, which means it cuts these into two equal pieces. So QM is equal to MR. So I can say 6x minus 11 equals 2x plus 9. So the first thing I want to do is solve for x. So minus 2x Alright, so 4x is going to equal 9 plus 11 is 20. Divide by 4, x equals 5. Alright, now what do we need to find? We need to find MN. Well, we're given QM or MR. Okay, so MN is going to be twice MR because this line bisects it. So we have to find MR first, and then we have to double it. Okay, so make sure again that you're not just solving, that you actually are answering the question that it asks. So MR is 2 times 5 plus 9. So I'm going to have 10 plus 9, or 19. And then 19 times 2 is 38. So MN equals 38. And again, the reason I know that is because MR is this segment here, and we need to find MN, and we know it's twice that because it has a perpendicular bisect that cuts it in half. So if we have half of it, we just double it to get the whole distance. All right, for number 12, it says the measure of CI, that's here, is 7x minus 15. And the measure of EF is this. So we have the measure of this whole arc, and what do? So we know that this piece is bisected here, so we have to double it to get the whole arc here. So we can't say this equals this, so be careful with this one, because this one just says CI. So twice CI would be CD. So I'm going to have 2 times 7x minus 15 equals EF is this whole arc over here. All right, so then we distribute the 2, so that's 14x minus 30. And then subtract 12x from both sides. Add 30. 2x equals negative 8 and 30 is 22. Divide by 2. X equals 11. All right, now let's go back and see what it asks for. It says find the measure of CI. So CI is going to be this right here. So we're going to say 7 times 11 minus 15. So 7 times 11 minus 15 equals 62. So the measure of arc CI equals 62. Now if you want to check yourself, you can say, okay, what does this equal? Okay, so when I plug 11 into here, this equals 124. And so CI is half of that. So it's 62 times 62, 62 times 2, or 62 plus 62, is that equal 124? Yes. So that is a way to check it and make sure that you did it correctly. All right, so number 13 and 14, it says use the circle below. We're going to skip 14 and 16 just because you have to use trig to do those, and you will do the same thing on your homework. All right, so number 13, find VW. So we're looking for this distance here. When I look, I see 5 and 13. This is huge on the ACT. So if you know Pythagorean triples, 3, 4, 5, 5, 12, 13. If you don't know what a Pythagorean triple is, look it up. These are very common on the ACT. 60 questions in 60 minutes, you need to be able to find this very quickly. You could use Pythagorean theorem to find this distance, but if I know 5 and 13 are here, this one has to be 12. 12 and 12 is 24. So VW equals 24. Quick and easy. All right, last one. So we have HK. HK is this line here, so it's 30. So we know that this is 15. And PM is 8. So that means this is 8 as well. Okay, so this ends up being a Pythagorean triple as well. So again, if you know your Pythagorean triples, you know 8, 15, 17, your hypotenuse is always your longest leg. PH equals 17. If you don't know what a Pythagorean triple is, I would look it up before the ACT. That can save you a ton of time. So 3, 4, 5, 5, 12, 13, and 8, 15, 17. There's more, but usually these lower number ones are the ones they see the most on the ACT. Have a good day.